Okay, let's do section 2.6, number 11 and number 12. Let's start with 11. It says sketch a graph of this and explain why it's invertible. Well, x cubed looks like comes up, goes through 1, goes through 0, then goes through minus 1 at minus 1, go through plus 1 at plus 1. And if I were to compress it by a fourth, it would just flatten it out here. And at 2, it's 8, so it would end up going through 2. So it's going to flatten it out. And then adding 4 moves it up. So it's going to look like 1, 2, 3, 4. And at 1 more, it's going to be up a quarter. And at 2 more, it's going to be up 2 more than 4, 5, 6. And it's going to go up, and it's going to go down. Something like that. And since it passes the vertical line test and a horizontal line test, it's 1 to 1, which makes it invertible. Because when you change it, it'll be a mirror image that goes through 4 and goes up like this. Mirrored over y equal x. And this is a function, and the inverse is also a function. Write the inverse for it. So that's when you switch the y and the x. So I'd have x equals 1/4 y cubed plus 4. Undo this, we'd subtract the 4. Then we'd have to multiply by 4 to get rid of the fourth. And then we'd have to take the cube root to get rid of the cube. So this is the inverse. I'm going to distribute the 4 in this, so it's the cube root of 4x minus 16. So if I need to find the derivative of the first one, so the derivative of the original, that one got off page. Derivative of the first one is 3/4 x to the 2, and the derivative of that is 0. That's f prime of x. And the inverse, they want us to call it g. So f inverse of x, which they want to call g of x, is this 4x minus 16 to the 1/3. So g prime of x, the only reason they give us another name is because it's hard to write inverse prime. It looks confusing. So they have us write the inverse of this function, or the derivative of this function, which would be derivative of the inside times the derivative of the bigger picture, something to the 1/3, which would be 1/3 of the something, to 1 less than 1/3 is negative 2/3. If I could rewrite this as 4 over 3 cube root of 4x minus 16 squared, either on the inside or outside. Okay. And then they're talking about 2 and 6 a lot. if you go to the original function and plug in 2, 2 cubed is 8, and a fourth of 8 is 2 plus 4 is 6. So this graph, the original graph, goes through 2, 6. Which means if on the inverse, there must be a place that goes through 6, 2. And the slope at 2, 6, we'd put 2 into the derivative of the original. So the derivative of the original is this. So I put 2 in there. I get 2 times 4 is 8, minus 16 is negative 8. And the cube root of negative 8 is f, whatever, right here. This is the inverse. I want the derivative. I got to put it in here. 2 into here. 2 squared is 4 times 4 thirds. So f prime of 2 is 3/4 times 2 squared. I said it wrong before. This is 4, cancel the 4, and I get 3 as a slope. This should have a slope of 3. Looks reasonably right. So over here, since it's a reflection, this should be 1/3. So now I'm going to take G prime and plug not 2 in, because we're now going to the point where x is 6. It was 2 on this one, but it's 6 on this one. So I got to plug 6 into this equation. 4 times 6 is 24. Minus 16 is 8. 8 squared is 64. The cube root of 64 is 4. So this whole radical is 4. Cancels the 4 in the numerator, and I end up with 1/3, which is the reciprocal of that one. So the slope at the point 2, 6 on the original is the reciprocal of the slope of the inverse at 6, 2. At 2 on this one, at 6 on this one, slope goes from 3 to 1/3. Okay. Sketch a graph of this. Well, it's going to be x and the sign's 0, and then it adds 1, and then it goes to 0, and then it subtracts 1 from the line, and then it adds 1, and so it looks something like this. And it's invertible because it is also 1-to-1. Passes vertical and horizontal line test. The best of the graph music technology. It must be invertible. Explain why it does not appear that you could find the inverse. So to do that, you're supposed to change the y to an x and x to y's. And there's no nice way to solve for y in this. So algebraically, it's not possible to find a formula for the inverse. But we're going to use what we learned in 11 to actually find the inverse. Now they say this point lies on the graph. Let's check that. It says put pi over 2 in for the x. So h of pi over 2 would be putting pi over 2 in for the x. plus sine of pi over 2. And if you remember your trig, the sine of pi over 2 up here, the y value is 1. So this is 1 and this is pi over 2. So h of pi over 2 is pi over 2 plus 1. So that's why it goes through this point. And so if that's a point on the original graph, a point on the inverse is pi over 2 plus 1 pi over 2. Inverse swaps the x and y. So this is on the inverse. And the slope of the inverse at this point, with that for the x value, is the reciprocal of the original slope. So we're going to go back and see if we can find the derivative and calculate the slope. So h prime of x is going to be the derivative of x plus the cosine of x. So if I plug in pi over 2 into this, I get 1 plus the cosine of pi over 2. The cosine of pi over 2 on the unit circle is 0. So the slope on the original graph is 1 at pi over 2. So over here, pi over 2, it says the slope was 1 at that place. Wherever that is, it's got a slope of 1. So therefore, the slope of the inverse function at the y-coordinate where we just calculated slope, not at this point, at this x-coordinate, but at this x-coordinate of the inverse, the slope of h inverse of x slope it at pi over 2 plus 1 has to be the reciprocal of 1, which if the 1 is 1 over 1, the reciprocal is 1 over 1, and it's 1. So the slope there is 1.